Okay, in part D, you have to find an estimate for the gradient. Okay, remember gradient is steepness or rise over run. Okay, rise over run, and doing an estimate for a curve. So what we'll need to do is we'll need to find our curve. Okay. And we'll need to get our ruler and draw a tangent, okay, and then find the estimate the gradient of this of the tangent. The way you do that is by finding a convenient triangle underneath the line. Okay, so going back to graph. Okay, so where x equals -1 is here. And so that is where I'm trying to find an estimate for that point there. Okay, so I'm going to get my ruler out and draw it. So you want basically for the angle, this angle just between here and here, to be roughly equal. So it's just touching, and get a graph like that. Okay, so I'm going to try and find a convenient triangle under here. Okay. And for that, really what I'm looking for is a single step from left to right, okay? And I can kind of see if I go from here to here, I will have traveled +1 in that direction. So that would make my run, okay, nice and easy, +1, okay? Let's have a look at the rise, okay? So here's my triangle. If I draw my triangle in carefully for that point, okay, I'm going from this point to this point, and this point to this point, and if we look at it carefully, it looks like so. And by the way, hopefully you realise that if you walk from left to right, or you read from left to right, and anyone walking along this slope, okay, is going downhill. Okay, so it's going to be negative. But each one of these is 10, so just be aware of your scale. Okay, so here I'm going down 5 when I get to that point. Okay, go down 5, 6, 7, 8, 9. I make it actually -9. Remembering each one of these little squares, is a single one. Okay, because each square is 10. So I think there are 9 little squares there. So my rise is -9, and so as my run is rise over run -9 over 1. My estimate, okay, is going to be -9 over 1, in other words, -9. Okay, next part of the question. Again, this is definitely an A-star section of this particular question. Okay, so here, my inputs go here, don't they? So my inputs go here, between the brackets, and my outputs are here. Okay, they're saying that k is a number. K is a regular number. Okay, and it has where k is a number has 3 solutions between x equals -2 and x equals 4. Okay, so we've got to work out when will this thing have 3 solutions. Okay, well, let's just first of all find an easy area. Now I've drawn massively over this graph. So I think I'm going to have to try and use, I'll use a highlighter. So if I was to draw a line here, in fact, let us have a look at, can you see where x equals 4 there? So 1, 2, 3, 4. Okay, if I draw the y equals 4 line, remember the y equals 4 line is a horizontal line, not a vertical line. So this is the y equals 4 line, or the output. Remember, y coordinates are output numbers. Output equals 4 line. Okay, you can see that there are 3 inputs that would create that solution. Okay, one here, one where we had before, one, and another one over here. Okay, so just about there where that graph is. That would generate an output of 2. That would generate an output of 2, and so would this. Okay, but what are they? They're talking about some sort of inequality. Well, it comes to a point that if I raise this line, the y equals 4 line, the output equals 4 line. If I raise it to 6, okay, at point 6, I only get one solution. okay, or no, don't tell a lie, I get 2 solutions here, because I get this one from x equals 2, and I get another one for x equals -1 would also give me an output of 6, okay. The drawing is a bit tricky, but hopefully you can just about make out what I'm saying. So x equals -1 gives you an output of 6. So there, I only get 2 solutions. But as soon as I drop below, okay, this is the y equals 6 line, or the output equals 6 line, okay. As soon as I get below that, okay, I'm in this region where you're going to get 3 solutions. You get 3 points of intersection. Okay, and then also I believe that if you get to this point here, where the y equals 2 line, I also only get 2 solutions. Let's draw it in. Okay, so here I've got the y equals 2, or the output equals 2, okay? And here I'm only going to get 2 solutions, but as soon as I'm above that line, the horizontal line is going to cross in 3 separate places. So my answer to this question is that so long as your output is below, if your output is below 4, no, so tell a lie, output is below 6, okay, this is the point where I only had 2 points of intersection, or your output is above 2, so anywhere between there, you're going to get 3 solutions. Okay, anywhere between these 2 bits here. And so my final answer is that k must be 2 must be less than k, which must be less than 6.